other ratio covered in Chapter 4 that you are asked to calculate is called a compression ratio. A compression ratio is defined as the expanded volume over the compressed volume. In an automobile engine, there's a large difference between the volume of the cylinder space when the piston is at the bottom of the stroke and when it is at the top of the stroke. The difference in volumes is called the engine displacement. Automotive mechanics find it useful to talk about the compression ratio of an automobile engine. The compression ratio of an engine compares the volume of the cylinder at maximum expansion, or the expanded volume, to the volume of the cylinder at maximum compression, or the compressed volume. Also, please remember, very important, compression ratios are always written so that the second number in the ratio is 1. And we'll discuss that here in just a second. So, back over here to the problem. It asks us to find the compression ratio. We just discussed that. So, remember, when you're doing a word problem, underline important words in that problem. Now, sometimes you'll have something that's called a distractor, but you won't really know that until you get to the part where you write an equation for that word problem in order to figure out what the answer is. So, let's just read through this. It says a small gasoline engine, okay, small, that could be important, has a maximum cylinder volume. Remember that from our what we just discussed, that a compression ratio is defined as the expanded volume over the compressed volume. And when your book was talking about this expanded volume, it also referred to it as maximum expansion. So right now in our word problem, we see a maximum cylinder volume of 520 cubic centimeters. Okay? So we're going to go ahead and write that there. 520 cubic centimeters. You can write cubic centimeters out like that, or you can put it like that. Doesn't matter. And a compressed volume, which literally is the same thing, compressed volume of 60 cubic centimeters. However you want to write that out. But remember from the last problem that we worked, 1A, that in ratios, the unit of measurement, which in this case is cubic centimeters, it's on both on the top and the bottom. It doesn't matter. A ratio is not going to contain a unit of measurement. It's just a ratio. One number as a ratio to another number. So now we were able to get rid of these two. We'll rewrite this as 520 over 60. And that's our ratio. However, remember, when you're doing a ratio, you want to get your fraction to the lowest terms. Alright, so we know just by looking at 520 over 60, both of those numbers are divisible by 2, so that fraction right there is not in lowest terms. Also, as I just stated, when you're working with compression ratios, they're always written so that the second number is a 1. Okay, so the two things you need to remember when you're doing compression ratios. One, general rule for ratios, so the fraction needs to be in its lowest terms. And then specifically for compression ratios, it's always written with the second number is 1. Okay? So, I saw what some of y'all did, which is that you decided to get this in lowest terms, which is great, and you decided that a number that you could take out of both of these numbers bigger than 2 because of the fact that there's a 0 there, you said 20. So we're going to divide this ratio by 1 in the form of 20 over 20. And so when you divide 520 by 20, instead of having to do long division, this is one of those times where if you're just showing me how you're getting from 520 over 60 to another number, you can just show me on your calculator that you divided 520 by 20 to get the number 26. Okay? And then 60 divided by 3, 60 divided by 20 is going to be 3. And so some of you guys wrote this as your answer. Now, I accepted it because of the fact that you did not know, or you perhaps more than likely were not aware that compression ratios require that they're always written with the second number as 1, okay? So you may have had this, you may have had 26 to 3, you also may have had 26 with the colon, 26 to 3. I accepted those. However, in this case, because it is a compression ratio, moving forward on a quiz, on a test, on a final exam, you're going to need to make this bottom number or the second number a 1. And the easiest way to do that is to divide 520 by 60. So we'll get our calculator out again, and we're going to divide 520 by 60, and we get 8.6. So we could write 8.6 repeating over 1 is the reduced fraction. And now we also have that the second number is 1. But instead of having that repeated 6, what we can do is just use a fraction on top and say 0.6666666 or 0.67 is the same thing as saying 2/3. So you could just say, you could just say that it's 8 2/3 to 1, or preferably write it something like this, 8 2/3 to 1, using that word 2. And remember, we're saying to 1 because with compression ratios, the second number is always going to be a 1. Or you could use the colon and say 8 2/3 to 1. And so these 3 answers here would be more correct. I did accept these 3 in this instant because you weren't possibly aware of the rule that compression ratios are always written with the second number as a 1.